calculator go?
And Professor Pete and...
What do I do? Oh, I know. I can call the math detective.
So, I understand that there's a little beef with Kreppel.
Hello? Is this the math detective? I lost my calculator and I don't know what to do. Can you help me?
A rivalry. I don't think that there's a rivalry.
Is it? Here,
Does someone call the math detective? Yeah, that's me. I'm here to help you find your calculator. So, the only way to find your calculator is to do math problems that don't require a calculator.
I don't know how to do these without a calculator. Can you help me?
Yes, that's why I'm here.
Okay. Alright. So how do you do this one without a calculator? Like, if you just try to plug in 0, it just comes out to 0 over 0. I don't understand.
That's when we use this fancy rule called L'Hopital's rule.
How does it work?
So, when you get a limit when the answer is 0 over 0, what you do is you take the derivative of this whole thing and then plug in 0 again until you get an answer that's not over 0.
Okay, so the derivative of the top is 2, my pencil doesn't work, is 2 minus cosine x, right?
Mm-hmm.
And the derivative of the bottom is just 1.
Mm-hmm.
And so then you plug in 0, right?
Mm-hmm.
So then that's 2 minus cosine of 0,
Mm-hmm.
which is 2 minus 1, which is 1.
Mm-hmm.
Thanks. All right. How do you do number 2?
So for this one, we have to use the chain rule.
What's that?
So what I like to do is change this to x cubed minus 4x to the 1/2 power.
Oh, yeah, because the square root is the same thing as raising it to 1/2.
Yeah, and then you just move the 1/2 in front.
You move the 1/2 in front, and then what?
So you move the 1/2 in front, and then x cubed minus 4x to the negative 1/2, because remember when we take the derivative, we move this one in front and then subtract 1 from this number.
Oh, so then it's just
You
negative
have 1/2. And then we have to do the chain rule and multiply the whole thing again by the derivative of what's inside the parentheses.
Oh, so then just multiply it by 3x squared minus 4.
Perfect. And that's it.
Oh, cool. All right.
Oh my gosh, okay. Find the volume of a solid that results when the region bounded by y equals x and y equals x squared from 0 to 1 is revolved around the x-axis.
What does that even mean?
Okay, so let's first draw out the curves.
Okay. So y equals x is just a straight line, right?
Mm-hmm.
And x squared is a parabola.
Mm-hmm. Perfect. And then we just want to go from 0 to 1, where they intersect.
So 1 is like here.
Yeah. Perfect.
Are they intersect there?
Yeah, they intersect at 1.
Oh, I must have drawn it wrong.
It's okay. Just make those connect over there.
There. 1.
Perfect. Okay. And then what we're going to do is when we say revolve it around the x-axis, all we're going to do is just flip it over and redraw it on that side.
Okay.
Just do like the opposite.
Like that?
Mm-hmm.
Okay.
And then what you want to do is draw a disc from these 2 lines and one from the outer line to the other outer line. Perfect. Now what you want to do is find what the 2 radiuses are from the x-axis.
So that one is just from the x-axis to x squared, right?
Mm-hmm. So you can write a little r equals x squared.
And this big radius is from the x-axis to x. So it's just x, right?
Yes, perfect.
So then how do you do it?
And then when you want to find the volume, you do pi, right? Because when you're doing volume, we always have to include pi. So pi times the integral of big R squared minus little r squared.
So x minus x squared.
And then square each of these 2.
So it's like pi r squared.
Yeah, exactly.
Except for you have 2 radiuses.
Exactly. So then that should turn into pi times the integral of 0 to 1 x squared minus x to the 4th. Perfect. And then you just find the antiderivative and plug in the numbers.
So that's 1/3 x cubed minus 1/5 x to the 5th from 0 to 1?
Yeah.
Alright, so all of this cancels because they all go to 0. And this is just pi times 1/3 times 1/5, right?
Minus 1/5, yeah.
Okay, so then you have to simplify the fractions. That's 5/15, and that's 3/15. So volume is equal to 2 pi over 15, right?
Yeah, perfect.
Yay, we did all of them. I still haven't found my calculator, though. It looks like I didn't even need them to solve these problems.
Exactly. There's so many problems you can do without a calculator.
Wow, I didn't even know.
Amazing. I don't see your calculator anywhere. Let's see. Scanning, scanning, scanning. Hey, look on that desk over there.
Oh my gosh, it's been right there this whole time?
Oh my gosh. Perfect. Now you can do both parts of the calc test, the ones without a calculator and the ones where you do need one.
Thank you so much, Math Detective.
No problem. See you next time.